Hey class, today we're going to be looking at lesson 1-9. This lesson should be fairly short, so we're going to just be looking at scientific notation. This is a good build on what we just did in our Desmos lesson today. So we're going to use scientific notation to write very large or very small quantities. So scientific notation, we wrote this in the last lesson, but it is written out as A times 10 to the power of a number, and that's an integer, so n, okay? And a has to be bigger than 1 and less than 10. So we're going to look at some examples with this today. So let's say we have, standard form is just like the typical way we write numbers. So let's say we have 1,340,000. To write this in scientific notation, we would write this as 1.34, and we count, so this a value had to be bigger than 1, less than 10. We have our decimal here, and we count 1, 2, 3, 4, 5, 6. So it is 6 decimal places. So we will take times 10 to the power of 6, okay? We could also have a really small number and write this out as 4.2, and it would be 1, 2, 3, 4. So times 10 to the power of -4. So if it's really small, that value is negative, okay? So write large numbers in scientific notation. Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.26296 times 10 to the power of 7 miles. In an astronomy book, she found the following. She found this distance. Which distance is correct? So her father said that it is 9.96 times 10 to the power of 7. And in the astronomy book, it said 92,960,000 miles. So we can rewrite this as, in scientific notation, we'll write it as 926. Why do I keep writing a 6 there? 96000. Just add zeros, but we have to count how many decimals it's going over. It is going over 7 decimals. So 1, 2, 3, 4, 5, 6, 7. Okay? Some people would do it this way. They would count 1, 2, 3, 4, 5, 6, 7. That works, but be careful because then you want to make sure you're filling the zeros inside here. And I got a shaky hand. All right? So we have, and then we add our commas. So we can see that 92,960,000 is the same as what's in the astronomy book. So who is correct? They both are correct. All right, so you can go ahead and try this one on your own. So it should be 3.212 times 10 to the power of 123. Okay? Write small numbers with scientific notation. So we have this really small number here, 0.0000. We have 1, 2, 3, 4, 5 zeros, 703. So we can count our decimal place. 1, 2, 3, 4, 5, 6. So it's going to be 7.03 times 10 to the power of -6. All right, so a common mechanical pencil lead measures 0.05 meters diameter. How can you express the measurement using scientific notation? Go ahead and do that. So you should have gotten 5 times 10 to the power of negative 1, 2, 3, negative 3 meters. Don't forget your units, okay? All right. On a calculator, you can use scientific notation and you can read it out. We're going to convert scientific notation in standard form. So Kelly uses this calculator to multiply large numbers. How can she write the numbers on her calculator in standard form? So this form here, 3.5, E is actually just telling us that it is times 10 to the power of 15. So this is 3.5 times 10 to the power of 15. So in standard form, that is 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I believe that's correct. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we'll add our commas in here. That'd be 3, 2, 2, 2. There we go. So this one will be 8 times 10 to the power of negative 9. So in standard form, that is 0. And we'll have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then the 8. And we can count that to make sure it is correct. We would move it over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So go ahead and write these numbers in standard form. Now that you've done that, I will check it because I'm not going to write all those zeros. Actually, I will. 9. Actually, no, I will read it. I will count all those zeros. All right? Write down any questions that you may have. Let me know if you have anything. Have a great day.